All right. So this is a follow-up status update on the VPlan+RV presentation I gave at last year's US Dev meeting. So first off, this is about VPlan+RV, the project. What is VPlan? Well, this is basically Intel's proposed new vectorization infrastructure for LLVM. So Diego gave a talk about this yesterday. This is currently under development. What is RV? Well, RV is the whole functional outer-loop vectorizer that is developed by a group that's available today. You can just write pragma SPMD at your outer loops and run our code. It will be vectorized. And so today's talk is basically about the status update, namely about the divergence analysis we're going to upstream to LLVM. And later coming up in future patches, future work is also our work on partial control flow linearization, on which we have a paper on this year's PLEI, which is for irregular control flow and vectorization. So divergence analysis, what is that all about? So say, suppose we wanted to vectorize this loop nest, in this case, the outer I loop. Then we want to find out which values are uniform across all lanes and which vary. So for example, this variable univar here will only ever have the same value in all lanes because assuming f doesn't read memory, doesn't write memory, is safe in a way. It only depends on I. I is, okay, in this case could be j. Anyway, so assume this was j. Then this would be a uniform value because you would execute the inner loop in lockstep, so everybody will see the same value of j and then the same value of f of j. And down here, this varying variable, for this one you will see different values in the lanes potentially because it depends on I. And so I is basically just a thread index, so you could see different values here. And this is crucial information to generate code in the vectorizer and to analyze and to have set up proper cost models. So, and we've integrated that with the loop vectorizer. So there's a VPlan+RV fork of LLVM on our GitHub. And the problem is basically the current loop vectorizer isn't really that interesting because it only supports innermost loops. There's a single basic block, so there's not really much we can do, but you can run like the entire test suite and it goes through without any performance difference. But we have some unit tests that show what's possible with it. And so this won't be relevant, therefore, for VPlan before our patch series number 3. So in the meantime, let's fix LLVM's divergence analysis, which already exists for ND-PTX and AMD GPU. So there already is a divergence analysis, so what's the problem here? So consider you got the CFG here, and you got a divergent branch in your block A. So divergent branch means you branch on a varying value, so that varies across the lanes. So we'll find out that actually this phi node here will become varying because this branch here is divergent. Because you can come from the left and from the right in a single SIMD package. So that's fine, that's okay. And it will also tell you that this phi node here is uniform. Yeah, that's actually wrong. Because you could come from the left here, and another thread could come from the right, taking this branch. So you join from 2 incoming blocks, and even if those values were constants or uniform, the result would be varying. So in brief, LLVM's current divergence analysis is broken for unstructured CFGs. Well, our analysis does support unstructured control and divergent loops and all that. It only has to be reducible. So to sum it up, so we have our VPlan+RV fork of LLVM, and there's like a core divergence analysis, which is generic, and we've instantiated that with a loop divergence analysis that you can currently use in the loop vectorizer by passing vectorizer USDA, or you can use it in a replacement for the current divergence analysis in LLVM for GPUs by passing -use or VDA as an option. And it will be used in structurized CFG and also in the backend work for ND-PTX and AMD GPU. Thanks.
Thank you.